Hello, everyone. Welcome back to another episode of Musa talking to himself for 2 hours straight. Today, we're going to be talking about simple harmonic motion, particularly the conditions that are required in order for a particle or whatever to follow a simple harmonic motion curve, some of the formulas in terms of time and some of the formulas in terms of displacement. Wonderful. So what is simple harmonic motion? Well, simple harmonic motion is when a particle oscillates in the form of a sine curve or a cos curve. So it oscillates between around some center and going up by the same amount as it does go down. So basically, it's when a particle follows a sine/cosine curve, okay, oscillating between 2 points. What are some things that follow this simple harmonic motion? I guess you could say, you know, those boys in the water, not small children, not small males, but the thing that measures how high or how low the water is. It's called BUOY. Yeah, well, those things which follow basically the tide, they follow simple harmonic motion, and they can be used to help model the tide at a particular point, the depth of the water as well. And why is that useful? Well, it's quite useful in determining when certain ships can enter into, I guess, the wharf or whatever, because they need a certain depth to be able to enter into that. So I guess it's useful. Wonderful. Anyway, we'll draw a bit of a curve and we'll talk about all the different parts of the curve which correspond to parts of the equation. So generally, something that follows in simple harmonic motion can follow one of 3 curves. The first is x equals a sine nt plus alpha plus c. The next is a cos nt plus alpha plus c. And then the last one is one where it's a combination of sine and cosine. So it's s equals, and then x equals something like a sine nt plus b cos nt. Okay, wonderful. So let's talk about what each of these parts represent and how they correspond to our curve. So let's take an easy example of simple harmonic motion, something that maybe follows a curve like this. We'll call this C. Now, C refers to the center of oscillation. Okay, so from where is it going up and from where is it going down? The A refers to the amplitude. Okay, so remember, A is a positive. When we say amplitude, we're always referring to a positive number because it's like you're going up by a amount and you're going down by a amount. But of course, here you could have a positive or a negative, and that would just determine whether you start from like this, maybe you start from like that. Okay, so that's what the A refers to. We'll call it, it's kind of like amplitude. Okay, N helps us determine the period. Okay, so I guess you should already know this, but the period of a sine curve is 2 pi. But generally, if you have the coefficient of t as being n, then the period is equal to 2 pi over n. So how can we demonstrate this on the graph? We could say the distance from here all the way to here should equal 2 pi on n. Lovely. Now that alpha, it's not really easy to demonstrate on this graph, but of course, the alpha represents the changes that have occurred, like whether there's been a translation left or a translation right. That's not something that is going to be easy to pick out. Maybe if they give you some pieces of information in the question, you can find the alpha, but a lot of times it's going to be ignored. Okay, wonderful. Now, why would you use a sine curve as opposed to a cos curve? The reason why you would use a sine curve, let's just sort of omit the alphas in this case. Let's pretend like they don't exist. You would use a sine curve because you know sine at the beginning starts at the center of oscillation, right? Like a normal sine curve does this. So it starts at the center. If for whatever reason, the thing that you want to model, it starts off at the maximum or it starts off at the minimum, of course, you would have to use a cosine curve, wouldn't you? Or you could use a sine curve and then shift it pi on 2. But you would much rather use the cosine curve. Okay, so the cosine curve is good because if you wanted to start at a maximum, you'd have it as positive cosine, right? And it would start off like this. Whereas if you wanted to start off at the minimum, you'd have it as negative cosine. And then of course, this C will then shift it up or down, depending on what the center is of oscillation. Wonderful, wonderful, wonderful. That's basically simple harmonic motion. Okay. Now, do I have any other points to make? No. I think what's worth doing is just going through a question, and that'll help us, I guess, gauge what each of these different parts of the formula mean. So worked example 6. Okay, that's not good. That just went away. It says a particle is moving in simple harmonic motion according to the equation, whatever this rubbish is. Write down its center, amplitude, and extremes of displacement. Okay, so I think it's quite easy that this trig function here is the thing that helps it oscillate, but that 3 is the thing that's helping it, that's telling us where the center is. So we could say part A, the center equals 3. Lovely, lovely. For what else do we need? The amplitude. The amplitude, I think that's pretty obvious as well. That's just 2. Okay. And then it says the extremes of displacement. Okay. So what that means is how high and how low are you going? Okay. Because remember, x is displacement and t is time. So this here is referring to how high / low you go. Wonderful. So I guess the upper extreme, if you wish, depending, I guess you can call it the upper extreme, but you can just say the extremes are, now how are we going to find the extremes? Well, if you start at your center and your amplitude is 2, means you're starting at 3 and then you're going up by 2, so you're going to get to 5, then you're going down by 2 and you're going to get to 1. So the extremes are x equals 5 and x equals 1. Sick. Okay, part B says determine the period, initial phase, and location at t equals 0. So, period, that equals 2 pi over the coefficient of t. The coefficient of t here is pi on 2. So it's that. Now, if my math is correct, that's 4. Wonderful. It says the initial phase. So if you go back to our formulas here, we see these alphas refer to our phase, which I probably should have marked in here. And just by looking at the equation, I think you can see that the phase is pi on 6. Nice. Which is alpha equals, brackets rather, equals pi on 6. And then it says the location at t equals 0. So you just sub in t equals 0. You get x equals 2 sine pi on 2 times 0 plus pi on 6 plus 3. So it's 2 sine of pi on 6. Now, sine of pi on 6 is just a half. So it's 2 times a half, which is 1, plus 3, which is 4. Nice, 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 nice. Okay. And then part C says, determine when the particle is next at the same location. Okay, so this is important. It says next, because of course, any sine / cosine curve is going to keep repeating itself, and it will be at the same location an infinite number of times. You just want to see the next occurring one. Wonderful. So what do we want? We want to solve when does x equal 4. So you're going to say 2 sine of pi on 2t plus pi on 6 equals 4. Oops, no, there was a plus 3, wasn't there? Yep. Okay, taking away 3 from both sides, you get 1 on the right-hand side, dividing both sides by 2. You get sine of pi on 2t plus pi on 6 equals a half. So when does sine equal a half? Sine equals a half at pi on 6. Remember, that's your first quadrant, which is otherwise known as 30 degrees. But because ASTC, the next time is here, when that's pi on 6. So you can also say 180 or pi minus pi on 6, and that'll give you 5 pi on 6. The next one's 5 pi on 6. Of course, you can keep going, right? Like you can even give me negative values, but I think it's clear from this, we're just trying to find the next time you're here. So I don't need to keep going. Obviously, this first one, if you take away pi on 6 from each of them, this first one's going to give you t equals 0, which is kind of obvious, because here you get now pi on 2t equals 0, and then that's 4 pi on 6, which is 2 pi on 3. Okay, so you get t equals 0, which is the first one, but if you multiply the second one by 2 on pi, you get 4 on 3. 4 on 3. There you go. So that's the next time that you're at that location. Wonderful. So I think this first example is quite good because it just tells you what each of those parts are. You may even be asked to sketch this. I mean, Sack doing it here, but you should know how to sketch something like this. Okay. Remember the translations and all of that? Yeah, I don't think it's that bad. Okay. How about this? It says here, a weight is hung from a stand on a table by a spring and set in vertical motion. What the? The weight oscillates between 15 centimeters and 35 centimeters above the table, and it takes 2 seconds to complete one cycle. It is found that the motion of the weight may be modeled by simple harmonic motion. What is its height above the table 3/4 of a second after it passes through the lowest point? Bruh. Okay, so it seems like we've got to come up with some formula for this, yeah? Okay. So let's consider. It says it stood on a table, oscillates between 15 centimeters and 35 centimeters above the table. So I guess if you want to set the table to be equal to 0, to be x equals 0, like let's think about what's happening. Call this the table at x equals 0. Obviously that's time and this is x. Where is it oscillating from? It's oscillating from here. It's going all the way up to 35 and then all the way down to 15. Okay. Wonderful. It's hung from a stand on a table by a spring set in vertical motion. Nice. So it seems like whatever it's doing, it's kind of going from the middle and it's doing something like this. Nice. Well, if those are your extremes, how can we find the center and how can we find the amplitude? Often you get questions like this, yeah, where you're given the extremes. Well, if the highest you're going is 35 and the lowest you're going is 15, shouldn't the center be the middle between them? Yes, it should. So C for center should be the 15 plus the 35 on 2, which is 25. Okay, so yeah, I guess that's that. So this is 25. And if you're going from 25 up to 35 or from 25 down to 15, it means the amplitude should just be 10. Okay. Wonderful, wonderful, wonderful. Now, is it saying something? Is it saying it's starting at a particular position? Doesn't really say any. Oh, actually, we have this other piece of information. It takes 2 seconds to complete one cycle. So I think we can find the period. So that means 2 equals 2 pi over n, which means n equals 2 pi on 2, which is pi. Sick. The question doesn't tell us you start at the peak, or you start at the center, or you start anywhere else. That's okay. It's not saying what happens at t equals 3/4. It's saying what happens 3/4 seconds after the lowest point. So that means it's fully up to us how we decide to set up this equation. We can use sine, we can use cos, and we can translate it however we wish. But to make our life super easy, let's just say it starts at the bottom. Okay, so instead of this, let's just say it does this instead. I hope you can tell that it doesn't matter, because it's not giving us anything about the initial position or anything about any position in general. It's more relative. It's 3/4 of a second after something has occurred. Wonderful. So if we start there, then we can come up with the formula. I think because we're starting at one of the extremes, using cosine is probably going to be worth it. Like, it's going to work. And then the n is pi, so it's going to be pi t plus our center, which is 25. Our amplitude is 10, but I think it should be negative because we're starting at the lower point. Because we're good. Now, what do we want to do? We just want to find what happens at t equals 3/4. So I guess we're subbing that in. So part A, at t equals 3/4, x equals minus 10 cos of 3 pi on 4 plus 25. What does that equal? Cos of 3 pi on 4 is negative 1 over root 2, which is negative root 2 over 2. So it's negative 10 times negative root 2 over 2 plus 25. So then that's 25 plus 5 root 2. Okay, keep in mind, different people could have had different answers for this. I could have used sine, but just had it translated. So I had a bit of a phase in it or whatever. Okay, so no dramas. For how long in each cycle is the weight at or below 18 centimeters? Approximate the answer corrected 2 decimal places. Okay, so that's why a diagram is really good. It's asking us to consider 18 centimeters, which is going to be, I guess, somewhere here. Now it's within 2 seconds. So, within each cycle. So remember that there, because our period was 2, that's going to be t equals 2. So I guess what we're trying to find is we're trying to find this point, or this time here, which I'm going to put in like a nice blue. Trying to find that, and we're trying to find that. So maybe if I can solve for the first time it equals 18, because there's a lot of symmetry with these cosine and sine curves, this first blue should equal this second blue in terms of the time period. Okay, so because that's the case, I'm just going to find this first t, and the time between 0 and t, I'm just going to double it, and that's the total time within one cycle. So part B says when x equals 18, let's find t. Uh, 18 equals minus 10 cos pi t plus 25. Subtract the 25 from both sides. You're going to get negative 7 equals negative 10 cos pi t. Divide both sides by negative 10. You're going to get cos of pi t equals 7 on 10. Of course, we don't know what this is. So I'll go to my radian calculator. And let's see what the values are. Of course, nt is going to equal cos inverse 7 on 10. And because I'm only dealing with the first occasion, I don't have to, find future values. Of course, I can find the next one Remember, ASTC, cos is positive here and here. So right now I'm finding this one. I can also find this one by taking 2 pi minus the cos inverse 7 on 10. But that's irrelevant. That's going to give me that. Okay, not needed. Anyway, well, that's not supposed to be n, is it? That's supposed to be pi. Pi. And then, of course, dividing by pi, this gives me a number. 1 pi cos inverse 7 on 10. 0.25. Okay, so that's that. But of course, actually, we should give a few more decimals. 318, 3111. 33111. And then this period is, or this occurs twice. So it's the total time will equal 2 times that 0.2531833111, which is equal to 0. And then it's 506, so it's 51 seconds. Very nice, very nice. Okay, so as you can see, coming up with the equation, if you can do that, everything else follows very easily from there. Okay. Coming up with the equation may be the hard part, but that's why drawing a nice diagram is going to make your life a lot easier. Okay, 666. Okay, so how about this question here? An object is in simple harmonic motion with a period of pi and 3 seconds. At a certain moment, its position is 3 centimeters above the center of motion, and it's moving towards the center of motion with speed 24 centimeters per second. Part A, determine its equation of motion and hence find its maximum speed, and find when it next has the same displacement corrected 2 decimal places. Okay, so this is the important thing that we can do with simple harmonic motion, which is we can find also the derivatives with respect to time. So we can find our velocity equation. We can even find our acceleration equation. Okay, so let's come up with a formula for displacement. Now, luckily for us, we only have a bit of information. We have the period is pi and 3 seconds. Okay, and then we have at a certain moment, its position is 3 centimeters above the center of motion. So at a 3 centimeters above the center of motion. Okay. We haven't been given any other information about the displacement equation. There's this whole speed business that's got to do with velocity. Okay. The fact that we have such little means we have a lot of flexibility with the formula that we choose and with the assumptions that we make. They're not saying that at time equals 0, the displacement is 3 centimeters above. They're not saying that at all. But there's no harm in us letting at t equals 0, x equaling 3. Okay. And there's no harm in us maybe choosing a sine curve as opposed to a cos curve. So I'm just going to show you a general equation, which is still supposed to encapsulate all of this. So let's say A cos nt plus alpha. They didn't give us anything about the center of oscillation. They just told us that at a certain point, you're 3 centimeters above that center of motion. So this is the center of motion. And there's some time where you're 3 centimeters above that. So it means we have the flexibility of choosing where our center of motion is. Let's just say, let center of motion equal 0. Therefore, C just equals 0. This just makes our life easier. We don't have another unknown, okay? Now, they told us something about the period. Period equals pi over 3. So T equals, and it's going to be 2 pi on n, remember? So that's going to equal pi on 3. And then I think from solving this, we get n equals 6. So now we know x equals a cos 6t plus alpha. Wonderful. Let's just leave it at that for now. Can we find our velocity equation? Yes, I just need to differentiate this with respect to time. So if I differentiate this with respect to time, the cosine goes to negative sign, so it becomes negative, and you multiply by the 6, so negative 6a sine of 6t plus alpha. Lovely, lovely, lovely. Okay. It says at a certain moment, its position is 3 centimeters above the center of motion, and at that same period of time, the speed is 24 centimeters per second. Well, let's just say that happens at t equals 0 to make our life even easier. It doesn't matter. This can occur at a different point. It's just we're going to get a different value of alpha, okay? Because it's just going to be shifted around. So at t equals 0, we can say x equals 3, and x dot is going to equal, and let's just read, is moving towards the center of motion with speed 24 centimeters per second. So we shouldn't just put 24 here, because 24 means you have positive velocity. And what that might look like on a graph, remember this is x versus time, or displacement versus time. If you have positive velocity, it means the change in your displacement is positive, and therefore you're moving up, okay? If you have negative velocity, it means the change in your displacement is negative, and it means you're moving down. So if you're moving towards the center of motion, and we've defined the center of motion to be x equals 0, and you started off at 3, that means you have to have negative velocity because you're going downwards, okay? So this is going to be negative 24. Lovely, lovely. So now let's just sub this in. At t equals 0, x equals 3. So a cos, and then this is 6 times 0 plus alpha. And then we get another one, which is negative 24 equals negative 6a sine of 6 times 0 plus alpha. Okay, so I mean, let's just see how this works. What do we get here? 3 equals a cos alpha. And then here we get, if we divide by that, we get 4 equals a sine alpha. Let's just, now it's kind of like back in year 11, we have to eliminate the parameters. So I'm thinking square, 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 and then add. So we get 9 plus 16 equals a squared, then take this out of the bracket, sine squared alpha plus cos squared alpha. Obviously, sine squared plus cos squared is 1, so we get a squared equals 25, and then we get from here a equals 5. A could equal plus or minus 5, but because we're talking about just an amplitude, we can just say it's positive 5. Okay. Obviously, the alpha is the thing that's going to shift it around anyway, and that'll account for that. Now, we just go back to one of the equations. Let's say 3 equals 5 cos alpha. And we're going to say cos alpha equals 3 on 5, and therefore alpha equals cos inverse 3 on 5. Perfect. It says determine its equation of motion. So I guess we know now what it is, don't we? This is just going to equal x equals 5 cos 6t plus alpha, and we know what alpha is. And then the first derivative is negative 30 sine 6t plus alpha. Now, when you think about this now, maximum speed, well, isn't the speed equation or the velocity equation given by a sine curve? Now, because the amplitude is 30, doesn't it just oscillate between positive 30 and negative 30? So what's the maximum speed? Well, first of all, speed equals the absolute of velocity, right? So I don't care if it's going in the positive or the negative. So it seems like we're just trying to see what's the biggest number that our x dot can take. And because it oscillates between 30 and minus 30, the highest it can go is to have a speed of 30. So max speed is 30, and then whatever this was, centimeters per second. Nice. And then find when it next has the same displacement corrected 2 decimal places. So have a go at this yourself and pause and then unpause, and I'll just do it. So part C, or part B rather, is where's our equation? When is it in the same spot? So 3 equals 5 cos 6t plus alpha. We already know what alpha is, so that's good. I just don't want to write this out every time. That means cos of 6t plus alpha equals 3 on 5, which means 6t plus alpha equals cos inverse of 3 on 5. And what can we do from here? We can minus alpha and then divide by 6. Nice. Now that should give you the first one. The next time it goes to that is when you don't have cos inverse of 3 on 5. You have 2 pi minus cos inverse of 3 on 5. Why? Because on this thing, it could be there, or the angle could be, we won't even do that. It could be here or it could be here because it's positive. So the first one's just this one, and the second one is the 2 pi minus that. Nice. So it would be 2 pi minus cos inverse 3 on 5 minus alpha on 6. Now, luckily, alpha is the same thing as that. So the first one's just going to equal 0, which makes sense. That's how we set it up. And the second time it's going to equal 2 pi minus 2 cos inverse 3 on 5 on 6. My degree calculator, bro. So 0.74 seconds. Wonderful. Okay. So let's consider this next question, which is kind of like a follow-up of the question before. It's just telling us to use a different form. Okay. So this form is the one where you have a cos nt plus b sine nt. I personally hate this form because it makes solving for t's very annoying because you have 2 trig functions. When you have to solve for t's here, you're often obliged to do t form. I think that's what it mentions in part B, which majorly sucks. Or you can do auxiliary angles. Okay, so yeah, that also sucks, which is why it's easier to use forms like this. But anyway, it's good that you have to know how these ones work. Well, because the question's very similar, it's saying the period is pi on 3, which means again, we know what n is. N just equals 6. So let's just write x equals a cos 6t plus b sine 6t. Nice. And then to differentiate, we need to do our first derivative, and that's going to give us velocity. So this is going to be negative 6a sine 6t plus 6b cos 6t. And just like the question before, the limited information means we can make a lot of things just work for us, right? Makes our lives a lot easier. One of those things that we can do is we can say, because it says anytime, there's this particular point in time where you're 3 centimeters above and you have a velocity of negative 24, you can just make that at time equals 0. So say at t equals 0, x equals 3, x dot equals negative 24. I think this helps you find your a's and b's, because for the first one, 3 equals, and when you sub in 0, this is just because of, I guess, because of 0, my bad. And then sine of 0 is 0. So actually, I'll just chuck it in for the first one. Obviously, this goes, that just equals 1. So we get A quite easily as just 3. For the second one, negative 24 is going to equal, again, this one's going to go to 0 because it's got a sign of 0, but this one's going to go to just 6b. So dividing by that, we get negative 4. Wow, wow, wow. We found A, N, and B. Use the T form to find when the object is next at its original position. See, you have to use T form because you're solving for values of T. That's not the best reasoning, but you're solving for values of time. T form is for tan of theta on 2, but yeah, you get my point. You're working for an angle, and the angle is annoying when you have two trig functions. So what do you want? You want at x equals is next at its original position. We define the original position to be x equals 3. So I guess we're just doing that. Now, that's going to be, we want 3 cos 6t plus b, minus 4, my bad, sine of 6t should equal, and this should equal 3. Now, T form, the way T form works is you always let T equal to tan of half the angle that's given in the question. So we're going to say let T equal tan of, and it should just be 3T because it's 6T on 2. This allows us to use our T form identities. That's going to be 3 times 1 minus T squared on 1 plus T squared minus 4 times 2T on 1 plus T squared equals 3. Okay, multiplying everything by 1 plus T squared. We get 3 minus 3T squared minus 8T equals 3 plus 3T squared. Moving everything over, we get 6T squared plus 8T equals 0. Oh, let's go. Thank God. This isn't a quadratic. What can we factor out? We can factor out 2T and be left with 3T plus 4. T equals 0 or T equals minus 4 on 3. Okay, so T equals 0, that's when tan of 3T equals 0. So when does that occur? When does tan equal 0? It equals 0 at pi, 0, pi, 2 pi, 3 pi. So 0, pi, 2 pi. And that's T equals 0, pi on 3, 2 pi on 3. Next one, when does tan equal negative 4 on 3? That's when does tan of 3T equal that? Because we're dealing with all of this in radians, it's important to only consider the related angle, which we can say, let's let that be alpha equals tan inverse of 4 on 3. And now you can just consider which quadrant that's in. Of course, it's in this quadrant, and then it's in this quadrant because tan is negative. Right? It's negative 4 on 3. So that's alpha, that's alpha. So what can the 3T equal? The 3T can equal pi minus alpha, and then 2 pi minus alpha. What does the question say? To find when the object is next at its original position. Okay, well, I mean, clearly, this one's going to be the contender for the answer, isn't it? Because you wouldn't even deal with the ones afterwards, because this one's more than this, so this is the earlier one, and then this is pi minus alpha. That's still an obtuse angle, okay? Whereas here, actually, no, I'm mistaken. You would ignore this, you would ignore that, but this is an obtuse angle less than pi. This is pi. So when you divide them by 3, this should be smaller. This one. Okay. So let's find out what that value is. So that's pi. Let me mind wrong calculator again. Pi minus, and then tan inverse of 4 on 3. Left 3. This should equal 0.74 seconds. okay? Remember with T-form, you always have to go back to your original equation and check if pi over 2 is a solution, because the T-form does not allow for that solution, okay? In this case, it's not worth checking because pi on 2 is a bigger angle, because pi on 2 is 1.57, and that's a bigger angle than the one that we've got here. So even if it is a solution, it's going to occur after this. So we're just going to sack it off. Oh, by the way, 0.74 seconds. That was the same as part B to this because they're asking the same thing. Nice. Okay, hi everyone. Yeah, I guess I'm taking this from halfway. Got kicked out of the room, and then now I'm at UNSW. I'm sitting up there. I don't know if you can see around, but I thought I'd take a little seat here by myself and finish off this recording. Okay, so let's share my screen. And we should be good. So let's connect this. Alrighty, and I think we answered the last part to this question. Perfect. Now, the next thing that we have to talk about is simple harmonic motion, but with differentials in terms of x, not t. Okay, so what does this even mean? It's actually quite important because oftentimes, I guess in the real world, things are written in terms of their differential equations. What that means is you've been given the derivative, or you've been given the second derivative, not in terms of just time, like how often it is with the questions we've done so far, but in terms of x, so in terms of the displacement, or in terms of v, so in terms of the velocity. Well, simple harmonic motion follows a very particular rule. Something will follow a simple harmonic motion curve if the second derivative looks like a particular thing. So what we can say is that we have simple harmonic motion, if, and then what we have is x double dot equals minus n squared x minus c. So this is the most general form. You're told that the second derivative, so acceleration, should be written in terms of the n, which is often, like if you have sine of nt plus alpha, whatever, like say this is what your simple harmonic motion's displacement equation looks like. Then you're told that the second derivative equals negative n squared, so the coefficient of t, and then times the displacement, and then minus the center of motion, or the center of oscillation. So if you can prove that the second derivative of some function can also be written in this form, then we have simple harmonic motion. So I guess you could sort of see that, because let's say we did have x equals a sine nt plus alpha, you can see x dot equals a n cos nt plus alpha, and then x double dot equals, and then it's negative a n squared sine nt plus alpha, which of course, if I take it a negative n squared out, I'm left with, let's say actually I put a plus c, that's gone. Then it's a sine nt plus alpha, which if we just rearrange this first equation, you can see that means that a sine nt plus alpha equals x minus c. All right, so you can just sub that in and you get minus n squared x minus c. Wonderful, wonderful, wonderful. Okay, so perfect. If something follows that, then we have this sort of second derivative. Oftentimes, you might see it written like this.
x double dot equals minus n squared x. That's just because the c equals 0. So the center of oscillation is 0. Perfect. What I want you to do actually is I want you to show this to be true for, I mean, obviously the x equals a cos nt plus alpha 1. That's kind of easy. That's kind of obvious. I want you to do it for, because it follows the same thing as what we did for here. I want you to show it for this one. Show SHM for x equals a sine nt plus b cos nt. Okay, just have a go. It's really easy, but I just want you to see that it works. Perfect. Alrighty. Do I have any other points to make? Not really. I think just by recognizing this this second derivative, you can pick out some things, right? You can pick out where your n is, and then that can help you find your period. You can also find what c is. So I think there's an example here. The displacement x centimeters. Sorry, I don't know if these people are so loud or not, but this is very annoying. Okay, literally, I chose the furthest away from everyone I could possibly be. The displacement x centimeters of a particle at time t seconds satisfies x double dot equals minus 4 times x minus 3. The particle is initially at x equals 3 with velocity 6 centimeters. Determine the displacement time function and find when the particle is first at the origin. So what can we tell just from this second derivative? Remember, the general form is minus n squared x minus c. Get rid of this. There you go. So I think we can tell n equals 2. We can also tell c equals 3. So if we know that, we can start to write what our function looks like. Obviously, we have a plus 3, and then the period, we're going to choose either sine or cos, not the sine plus cos, because we want our life to be easy. It's going to equal 2 pi on n. So that's just going to equal, I guess we don't even need to, we don't even really need to find it. Sorry, a bug flew on my finger. So good. Okay. So because it starts at the center, I think our best bet is using sine, right? Like, oh, bro, these bugs are everywhere. Like 1, 2, 3. We're starting here, and that's our center. So it's kind of like a sine curve because we start at the center part. So it's going to equal a sine, and then the n was 2. So n 2t plus 3. Okay, wonderful, wonderful. Determine the displacement time function and find when the particle is first at the origin. Okay. Now, what else can we do? How can we find A? Let's see if someone's got some sort of a point they can make. Okay. This is very important. When your curve looks like this, this is a property about simple harmonic motion. This here represents your max velocity. Because remember, velocity is the gradient of your displacement curve. You can sort of tell that this is the steepest point, isn't it? And then afterwards, it's less steep, and then these are negative. And then here is like the minimum velocity. And when I say minimum, I don't mean like closest to 0. I mean the most negative. Most negative. Okay. So if I go down to my my first derivative, so my velocity equation, x dot's going to equal 2a cos 2t. And because we know we're a sine curve, all we can tell is that at t equals 0, we should have max velocity, shouldn't we? Now you might say at t equals 0, you could also have minimum if you maybe had a reflected sine curve that looks like that. Sure, I mean, you can say that too, but it doesn't actually matter. You just get a different A and the answers will still work the same because they haven't given us any extra information to differentiate between it being maximum velocity or it being minimum velocity. But we know we have maximum velocity. Another way that you know you have maximum velocity is because we can look at our second derivative. X double dot equals minus n squared minus whatever this is, minus 4, x minus 3. Wouldn't you say that you have the highest velocity when acceleration equals 0? I think so. Because here, you have a certain velocity, but it's concave down. Concave down means the second derivative is less than 0, or that means that you have negative acceleration. So it means you're slowing down. Then, here you have minimum velocity, right? Or the most negative you have of a velocity. But here you have positive acceleration because the second derivative is positive. So having positive acceleration when you have negative velocity means you're slowing down in the negative, right? You're decelerating in the negative. So whenever your acceleration equals 0, it means there's nothing opposing your velocity, nothing slowing you down. Okay. So that's why you know that you can tell from here at x equals 3, x double dot equals 0, which means you have max, we'll say speed, because it could be, you know, the most positive or the most negative, right? Depending on whether you're here or here or here or here. Okay, let's get rid of this pink one. Nice. So that's another way, because if x equals 3, we know t equals 0, so we can figure that out. Now, what's the maximum? Actually, we don't even, why don't I talk about that? Oh yeah. Well, actually, that's not even necessary. But anyway, it's a good point to make, and it might pop up on other occasions. In this case, it just says initially at x equals 3, velocity is 6 centimeters per second. So it means at t equals 0, x dot equals 6. So 6 equals 2a. That's cos of 0, which is 1, which means a equals 3. Nice. So a equals 3. And then I think we can put it all together, determine displacement time function. So now I guess we now know that x equals 3 sine 2t plus 3. And it's saying, when is the particle first at the origin? Okay, so let's just say x equals 0. Solving that, we get minus 3 equals 3 sine 2t. Dividing by 3, we get sine 2t equals negative 1. And the first time that you equal negative 1 on a sine curve is at 3 pi over 2. So 2t equals 3 pi and 2, which means t equals 3 pi and 4. And I think all the units for this were in seconds. So you'd say seconds. Nice. So this is a prime example of using the differential form, the one that's in terms of x, to be able to pick out certain things. And because we know what the displacement equation would look like in terms of t, we can just write a random one like sine or cos, and then fill in all the things as we get them. What's this question here? The motion of a particle satisfies v squared equals minus 2x squared plus 8x plus 10. Show that the motion is simple harmonic motion, then determine the period, the center of motion, the range, and the amplitude. Okay, I'm going to do this in 2 different methods. Okay, I'm going to do this in the... Oh, unfortunately, you got to show this one. That's what sucks. Okay, I'll show you both, and we can figure this out. Okay. Now. I want you to consider all the different forms of the acceleration we have in our reference sheet. X double dot equals d squared x on dt squared. We also have it as dv dt. I think we also have it as v dv dx. And we also have it as d dx over half v squared. Perfect. Well, we've been given a v squared equation. So if we've been given a v squared equation, it seems like if I just take half of it, half of that equation, and then differentiate it with respect to x, then I can get acceleration. So we're going to say x double dot equals d dx of a half of minus 2x squared plus 8x plus 10. And let's just expand the inside. It's minus x squared plus 4x plus 5. And then differentiating this, we get minus 2x plus 4. Okay, what do we have to show? Well, we have to show that this is simple harmonic motion. Okay, so how are we gonna figure this out? Well, we're gonna figure this out because, or how are we gonna show this? Because we're gonna take out a negative 2, we're gonna get x minus 2. Isn't this of the form x double dot equals minus n squared x minus c? It seems like c equals 2, and it seems like n just equals root 2. Very nice, very nice. So we can say, therefore, simple harmonic motion. Okay. Now, I want you to think about a normal sine curve. Okay, what's the next part? So, can we determine the period? Period equals 2 pi on n. Just 2 pi on root 2, which is root 2 pi. Okay, so we've done the period part. Then the next thing is center of motion. Okay, this is actually a sick way to do it. I want you to consider the sketch of any simple harmonic motion. I don't really care if it's sine or cos. I'm just going to do something random. Okay. Actually, we might even move it up there and take this whole thing and move it down a bit. Let's say this here is the center. Okay, we'll call this the center. Now, remember, if this is our x versus t equation, the derivatives will equal 0. So the velocities will equal 0 at these particular points here. V equals 0, V equals 0, V equals 0, and then of course, if that follows on, V equals 0. So if I set V equal to 0 from my equation here, where is this? This minus 2x squared, this rubbish. Remember, this is my v squared equation. So if I set v to equal 0, the x values which I'll be solving for will correspond with the upper and lower extremes. Does that make sense? I really hope it does, right? Because we know that v equals 0 there, because the gradients equals 0, then we can always make this, it's not even really an assumption, we can always make this deduction. So let v equals 0, we get minus 2x squared plus 8x plus 10 equals 0. Obviously, dividing by negative 2, we get x squared minus 4x minus 5 equals 0. And then we do this, and we get x minus 5x plus 1 equals 0, which means x equals minus 1 and 5. Okay, so, oh wait, what am I doing? Am I finding the center of motion? Oh, we already know the center of motion. It's x equals 2. Oh, no worries. So I should probably read the question before I do it. The range and the amplitude. Okay, so anyway, we have to do what we did here anyway. So the range and the amplitude. Well, how high are you going? You're going as high as 5 and you're going as low as minus 1. So the range should equal 6. And then what's the amplitude? Well, you're starting at 2 and you're going all the way up to 5 and you're going all the way down to minus 1. So it seems like we're adding 3 and subtracting 3, right? So your amplitude is 3. There you go. Okay. This is a pretty easy question, but I want to show you a different form. I want to actually show you how to get to a form for v squared where you can automatically pick out the n's, the a's, and the c's. So let's go to my second derivative. X double dot equals minus n squared, x minus c. This is the most general form. What I'm going to do is now replace this with d dx over half v squared equals minus n squared x minus c. Okay, and let's integrate both sides with respect to x. Integrating both sides with respect to x means we get a half v squared equals minus n squared x minus c all squared over 2 plus, and I'm going to call this d is constant. Okay, because we already have a c there. And then timesing everything by 2, we get, someone just crawl up. Bro, I should never have set that sign. What am I doing? V squared equals minus n squared x minus c all squared plus d. Nice. Now let's think about this. Okay. At our upper extreme, you can also do this with lower extreme. Our upper extreme. The x value would be what? It would be c plus a. Wouldn't it be the center plus the amplitude? Yes. Okay. The velocity should equal 0 because it's at one of those extremes. And we already showed from the graph that the velocity is equal 0 there. Okay. So let's sub that in. This is to help us find the c. So minus n squared, and then this is x is c plus a, so c plus a minus c all squared, plus d 0, 0 equals minus n squared a squared plus d, which means d equals a squared n squared. Nice. So if we write this all together, now that we know what c is, therefore we can write v squared as minus n squared x minus c all squared plus, and then a squared n squared. By just taking out a negative n squared, you get a squared and minus, and then x minus c all squared. Now, this is a very sick form. I used to always use this because if you were given your first derivative, if you were given your velocity like this, maybe you might say, this is way too much effort. But if I get it into this form here, then I can pick out the C, the A, and the N all at once. Granted, you would have to ask your teacher as to whether you're allowed to just sort of assume this, okay? Or do you have to show it every time? I don't know. Alrighty, so let's see how this works. I'm thinking we take a negative 2 out, and we get x squared plus 4x plus 5 minus 4x minus 5. No, this is plus. Bro, what am I doing? No, I think I messed this up. This should be x minus c all squared minus a squared. All right, there you go. There you go. Okay. Now let's complete the square on the x's. So we're going to x minus 4x plus 4 minus 5 minus 4 minus 2 x minus 2 all squared minus 9. And then now you can go, wow, my n is root 2, my c is 2, and my a is, if this is a 9, should make it look more like a 9, my a has to be 3. So that's another thing that you can do if you wish. Alrighty, and I think this might be our last example for simple harmonic motion. It's saying the motion of a body is plotted in the graph on the right. Assuming the motion to be simple harmonic motion, find the displacement time function. So what I'll get you to do is have a go. Try and figure this out for yourselves. Maybe you can find A and C and the N and the alpha. And I think if you do that, you're basically set. And you can choose, do you want it to be a sine curve or a cosine curve? I really don't care. Alrighty. Pause, unpause. Assuming you've just had a go, let's go through this. So the easiest things we can do is find our amplitude and our center. So this is 5 and minus 1. So shouldn't the center be the midpoint between them? 5 plus the negative 1 over 2. And that should be 2. Wonderful. So it means our center is somewhere here, 2. And then that's C. And if we're at 2 and we're going to go up to 5 and down to minus 1, it means our A should equal 3. Perfect. Now you can choose, do you want to use sine or cos? I really don't care. But let's just choose, it doesn't matter. Let's just choose cos, sine. So you're going to say 3 sine nt plus alpha and then plus 2. Okay. I want you to consider this. What's happening from here all the way to here. Isn't that one period? And that one period is happening in 4 seconds or 4 units. So then our period is going to be 4 equals 2 pi on n, which means n equals pi on 2. Very good. Pi on 2. The only thing we need now is our alpha. Perfect. Now it's saying at t equals 1 on 3, the x value equals 5. Perfect. So let's just sub this in. 5 equals 3 sine pi on 2 times a third plus alpha plus 2. Good. Minusing 3 equals 3. Bro, I don't know if you can hear these people, but they're like yelling for no reason. And then it's pi on 2. I mean, when does sine inverse equal 1, right? Pi on 2. Now you can choose pi on 2. You can even choose, I guess, what's the next thing? You can choose pi on 2 plus 2 pi. Your both answers are correct, right? Like it just means it's been translated by a full other period. Who cares? Anyway, this is the first one. It's the easiest. Then alpha equals pi on 2 minus pi on 6, which is pi on 2 minus pi on 6 times the first one by 2 pi on 3. Yeah, pi on 3. Oh, that was abysmal. And if they ask for the phase, just remember, you can't say your phase is, no, you can't say your phase is pi on 3 like this. Okay. My point was, say you factored out the pi on 2, and you got t plus, and then this would be, I think, if you take out an on 2, it means you're putting a 2 there. So t on 2 on 3 like this. You can't say your phase is 2 over 3. It's got to be in the expanded form, and then that's your phase. Perfect. So there you go. That's an example of this. I feel like it's not that bad. They're all the same formulas all over and over again. Nice. All right. I should probably stop this.